Today I'd like to talk to you about the waste heat generator 125 and how the organic Rankine cycle is utilized. We use a refrigerant called R245FA. We'll start our cycle analysis at the receiver, where we store the refrigerant in a stable liquid form at 24 degrees C and 2 bar. We take this low pressure liquid refrigerant and we run it through a high pressure pump, and we pump it up to 16 bar. We run it through an economizer to collect some heat in our process. I'll come back to that. What comes out of the economizer is now warmed high pressure liquid, 40 degrees C, and it's still at 16 bar. In the evaporator, this is where we absorb our waste heat. As it absorbs the waste heat, the refrigerant changes state from a high pressure liquid to a high pressure vapor. It boils just like water boiling on your stove. The high pressure vapor comes out of the evaporator and goes into our expander, and it's going to be at about 118 degrees C and 16 bar. As the refrigerant goes through the expander, it spins a turbine which generates our electricity. On the downstream side of the expander is low pressure. So as the vapor comes out, it's going to be at 2 bar and 62 degrees C. At 62 degrees C, it still has a fair amount of energy left in it that we want to capitalize on. As we pass this through the economizer, that energy that's left in that vapor stream is transferred to the liquid going to the evaporator, so that it pre-warms that liquid so that we keep that heat in the cycle. That's why we call it an economizer. The vapor then leaves the economizer and goes to the condenser, and it'll be at about 40 degrees C and 2 bar. We absorb in the neighborhood of 930 kW. Out of that 930 kW of heat, we generate 125 kW of electricity. The remaining heat we have to reject to the atmosphere. We do that in the condenser. As the refrigerant is released as the heat in the refrigerant is released to the atmosphere, it condenses the refrigerant back to a liquid, where it drains by gravity back to the receiver, completing the cycle.